Okay, so here we go. So we've calculated sales, we've calculated operating costs, we've calculated depreciation. So we subtract out operating costs and depreciate from sales, and we get this is actually EBIT, earnings before interest and taxes. Um, they we calculate taxes at 21%. So this is our net income. So the next page, we're going to calculate operating cash flow. So our the operating cash flow is going to be sales minus operating costs plus taxes. Since we don't have any interest expense, we can calculate it this way. So these are the operating cash flows. We have to add back our net cash flows that we calculated before. So we're going to do a NPV based on these cash flows. And so our NPV at 10% is 78.53 or 78,000. These are in thousands. So 78.53. So it's a positive NPV. So you would accept the project. So as long as if you calculate the IRR, these cash flows, it's 18.54%. So anything less than 18.54% for a required rate of return would result in acceptance of the project, as long as there's no other project available that produces a greater NPV. For example, though, if it was 20%, you would not accept the project. So, on your calculator, the CF0 would be the 260, CF1 would be 4370, CF2 would be the 5981, CF3 77.93. The frequencies are all one because none of these cash flows occur more than once. And then finally, CF5 is a 231.77. So, and then we enter I at 10% and NPV and compute. Whoops. Okay, go. Slow motion there. So get our 78.53. So that's the end of the Baldwin Company. Again, I'm going to do a separate lecture where I create an Excel spreadsheet to show you how to do this in Excel. It's I think it's much easier than trying to do it on paper. So alternative definitions of operating cash flow. Top-down approach. This is what we've been using. Sales, it's what we used in the Baldwin Company. Sales minus costs minus taxes. We don't subtract out the non-cash deductions. The bottom-up approach. This is the one we've actually been using. Works when there's no interest expense. So the operating cash flow equals net income plus depreciation. The tax shield approach is also another method. Sales minus cash costs multiplied by 1 minus the tax rate plus depreciation multiplied by the tax rate. So what this does give you the after-tax net revenues, and then you add back the benefit of depreciation. So special cases of discounted cash flows: cost-cutting proposals, setting a bid price, investments of unequal lives, cost-cutting proposals. Cost savings increase pre-tax income. So we have to pay taxes on that amount, so we have to recognize that. But depreciation reduces your tax liability. Does the present value cash flow associated with the cost savings exceed the cost? So is it worthwhile? If it's yes, then proceed. Setting the bid price. Find the sales price that makes the net present value equal to 0. So step 1, you use changes in net working capital and capital to estimate the preliminary NPV. Step 2, determine the yearly operating cash flow needed to make the net present value 0. Determine what net income is required to generate that operating cash flow. And then operating cash flow is equal to net income plus depreciation. And then finally, you identify what sales and what price are necessary to create the required net income. So this is a little bit like some of the problems that we worked in earlier chapters. There aren't any homeworks where you're actually asked to do this, so you probably thank me for that. So net income, sales minus cost minus depreciation multiplied by 1 minus T. So then next we have investments of unequal lives. There are some examples in the homework where you have investments of unequal lives. So there are times when the application of the NPV rule can lead to a wrong decision. So the example, a factory needs to install an air cleaner that's mandated by law. There are 2 choices. There's a Cadillac cleaner that costs $4,000 today, costs $100 annually and lasts 10 years. And then there's the Cheapskate cleaner that costs $1,000 today and has operating costs of $500, but it only lasts for 5 years. So you assume a 10% discount rate. Which should you choose? So if we calculate the NPVs, so it's the initial costs for about $4,000 for the Cadillac, $1,000 for the Cheapskate, and then the annual expenses are $100 for the Cadillac, and then $500 for the Cheapskate. But then we have the frequency. This is 10 for the Cadillac and 5 for the Cheapskate. So we head NPV and enter our I of 10%, and then we compute the NPV, and we see that the NPV for the Cadillac air cleaner is considerably more. The problem is that these 2 projects have different lives, so we have to take an additional step. So we're overlooking the fact that the Cadillac air cleaner lasts 5 more years, or twice as long. So we incorporate the difference in lives. The Cadillac air cleaner is actually cheaper. So what we are going to calculate is equivalent annual cost, or EAC. EAC is the level, the value of the level payment annuity. So we're going to annualize the cost of both of these projects. So for example, the EAC, or equivalent annual cost of the Cadillac air cleaner, is $750.90. So I'm sorry, the Cheapskate. So the Cadillac is $750. The Cheapskate air cleaner is actually $763.80. So it's actually cheaper to buy the Cadillac air cleaner. If we bought, for over those 10 years, if we bought 2 Cheapskate, and even if the price was exactly the same 5 years later, we would end up spending more money. So EAC, the calculator for the Cadillac, so that's all we're going to do is going to take the project, calculate the NPV. Now we're going to calculate a payment. So we've got 10 years at 10%, and the cost of that project is the NPV, the $4,614.46. We calculate that payment. Future value is 0 here. Compute the payment, $750.98. Now, if we go to the Cheapskate, we do the same steps. We calculate the NPV, and then we come over here. It's 5 years at 10%. So, and the present value or the cost of the project is $2,895.39. Again, future value is zero. The payment's $763. So, we reject Cheapskate and select Cadillac.